Hey everybody, welcome back to the Build Show Network. Steve Baczek here. We're going to have a quick conversation. We're going to talk about posts, columns, and we're going to talk about a little detail that I like to do in my houses down here. But let's start with the post. So we have different types of posts when we support basements and support loads in the building. Obviously above grade we can do a lot of wooden post, engineered wood columns, 4x4, 6x6 you're familiar with that. But occasionally the loads increase to such a level where we have to switch to something that's a little stronger and a little bit more efficient. So what I have here is, this is a 3.5 inch steel tube column here. You notice it goes down here, it goes down to a solid 8-inch base plate here that then gets grouted in. We level that off and then it gets some non-shrink grout. Now this is all going to get buried inside the basement and we'll have control joints around there, but that plate basically allows it to level out. And then as you come up here, notice that we actually have an increased size in the head plate. Now in New England, remember, we fur down our ceiling, so we get that 3/4 of an inch. But by having this increased size, look what the column does. It's able to pick up the beam going this way, but it also picks up the beam coming into it this way. And it all seats nice and neatly on that column. So all the load that's coming in here then goes down into the column. And then you notice down here, the column then spreads out to a wider footing, right? So if we think about our bodies, right, we're a column, but we go down to some pretty big feet. In my case, size 14. So yeah, we have it. But this is basically the feet of the house, that we can take all of this load, bring it down, and then we spread it across. So inside this concrete, it's about 12 inches. There's a series of reinforcing in there, so we don't get what's called puncture shear, where the column just simply pushes through the footing. We need that footing to be strong enough to push back on this column and support the weight, the reaction, if you're looking for the correct structural term. So the column comes down, we have that big footing, 3.5 inch square steel column, doing a little bit more work than normal. But if I go up and I follow that beam down here, you notice we come to something a little bit more traditional. So this is a tube column, or more commonly known as a lolly column. That's L-A-L-L-Y. They're typically concrete filled. So the concrete works really good in compression, but it doesn't offer much strength laterally. So they put the concrete inside there so you get the added compressive strength, but you wrap it with a steel belt, basically, which is the steel tube. And then that provides that resistance to lateral bending. Like anything, the taller the column, the more it wants to bend, right? It's kind of like the taller the person, the easier it is to push them over, usually. So that goes up. You can see in this case here, we have a standard lolly column cap. So there's a kind of donut-shaped ring there to receive it. The donut-shaped ring then goes into what's called a saddle. The saddle then carries the beam, but it also allows that beam to just simply continue on, right? So it literally just grabs that beam and allows it to traverse. A couple important things about it. The reason for the saddle is not only does it grab the beam, but you need to be able to get enough lateral distance of support here so that the beam doesn't break above the column. So just as the footing in the last steel column spread that load out, you get that load that comes across the LVL and it goes into the saddle. Well, the saddle takes the load from being something that's 3.5 inches to something that's about 9 inches long, and then brings it back into the column so that that load then comes down and gets supported by the concrete wall here. So, quick structural load path there. Now, if we take that beam and we follow it continuously down, you'll see it goes there and then it drops down and we have a series of 3 lolly columns down there, but we have a lower beam here and we have some smaller eye joists, 9.5 inches there. So basically you can see that the top of those eye joists align with the bottom of these eye joists. So what does that mean? It means upstairs we have a 14-inch displacement in the floors. We'll jump up there and we'll talk about what that 14 inches is doing for us. It's basically 2 steps. It's intentionally 14 inches, but you can see how that drops down. Now, if we follow that floor joist, and notice we have that center beam, which allows us to drop down. Remember, we talked about floor joists in the other video. We're able to go from the 14-inch down to the 9.5 because I've taken this 24-foot span and broken it into two 12-foot spans, which is very light work for those 9.5-inch floor joists. But if we come over here, you'll notice as the I-joist goes in, I actually have a drop in the concrete footing. It drops down onto a little shelf that then allows the load to get picked up from these floor joists down into the foundation wall without changing the height of the foundation wall. So on the outside of this foundation wall, it looks business as usual. It's a nice straight line. But inside here, I'm able to provide that shelf and provide that 14-inch drop in the floor assembly to solve the condition that we're going to talk about when we jump upstairs. So follow me upstairs and we'll take a quick peek on what's going on up there. Hey everybody, welcome back. So we're here in the studio, and we were just out there. We took a nice tour of the basement. We looked at some of the framing there. Remember, we had that 14-inch drop, and certainly a little pet peeve of mine, but let's talk about that a little bit more. And guess who we brought along? Our trusty friend, Big Red. All right. So I grabbed a small portion of the floor plan here. You can see it's a 3-car garage, basically 3+ car, but we have 2 bays here, and then we have a little sneaky bay here that slides in on the back side here. But most importantly, here's those 2 steps that we talked about. So the delta in that floor, that 14 inches, was between this floor and that floor. And remember, we talked about the beauty of that is to eliminate those steps so that you don't end up with, you know, this big staircase that goes from the mudroom down to the basement. There we just have a couple small steps that get you, take out those 2, get a couple small steps, gets us up into the mudroom. We get to do what we need to do down there. You can see down at the mudroom level, we have a powder room, we have a laundry room, we have a whole series of cubbies here and some coat racks and stuff happening down there. So that'll kind of service that transition from the garage to the house. But more importantly, it takes those steps and it pushes them inside. The other pet peeve of, you know, out here is that even as a big a garage as this is, and this one is 26 feet wide, which is on the larger side, all right, you start putting in these steps here and then you get in conflict with, you know, the car. And, you know, you're squeezing in, you're walking sideways to try and get up these stairs, or you're building a platform and you're coming down here. And, you know, you get out of the car here and you got to squeeze by. It wreaks havoc, in my opinion. So little design pet peeve of mine, bring that up. So that's what it looks like in plan. You know, you get a couple nice steps in there. We can do a nice tile floor down here. It transitions to the hardwood floor up there. Things look good. Things feel good. You're not climbing a lot of stairs. You're not turning sideways to carry groceries in the house. Let's see how we achieve that. Here is a couple excerpts from the framing plans. So this is the end of that floor framing plan here. You can see. But notice that we left this big section out, right? And I do that intentionally to illustrate that this is where the upper floor ends, and then the new lower floor happens here. So we have all those floor joists, we have the floor beams. We talked about those earlier. If you haven't caught my video on floor framing, I suggest you go back and check that out. A lot of really good information there if you want to really understand how we size floor framing members and how they actually work and how they work in concert with each other, and the floor sheathing, etc., and beam sizing, all of that good stuff, spacing. Great video, by the way. But anyways, you can see right there, it says see lower floor framing plan for this area, and then it calls out what the sheet is. So I brought that piece in right here. So this is that lower floor framing area. So we have those 2 LVLs that we saw in the basement, and those sit on this one beam here. And then these floor joists sit on the beam. But these floor joists and the floor joist there, which would be that one, there's a delta of 14 inches. And that 14 inches works out really nice because 14 inches is 2 7-inch steps, which are very comfortable to negotiate, right? And 14 inches is basically, if you followed along in that floor framing, you'd understand that that's the depth of our oi joist. So there's a lot of decisions here that work in concert with each other. We get 2 steps at 7 inches each. Those equal 14 inches. The 14 inches there is synonymous with our floor joist depth. It's not a coincidence. That's design intent. And then we have this lower section, like we spoke of earlier. Notice that the plumbing features are highlighted in red here. The sink, even though it falls kind of centered on that floor joist, not to worry, because the sink is elevated above the floor. We have the opportunity to manipulate that floor drain and water pipes to go around the floor joist. So sinks aren't really that big of a problem. The toilet is the big problem. And you can see we have that little toilet drain there, and it's smack dab in the center of that joist space. So we're guaranteed that that toilet isn't going to conflict with what we got going out there. So lastly, you see that in the floor framing plan. Let's just take a quick peek at what this looks like in building section. So this is a partial building section that I extracted from the larger one there. And you can see the area that we're talking about down here. There's that lower beam system. There's that lolly column. Remember, the lolly column is the concrete filled steel column that I talked about down there. You can see there's that line of first floor sheathing at the house. And, you know, consequently, there we are. 14 inches in height difference there also. So that coordination effort is across the board. It's in elevation, it's in section, it's in floor plan, floor framing plans, everywhere. But how did we achieve it? Well, typically on the house, you have your foundation, you have a band joist, and then we run our floor joist over the top of it. Well, to get that 14-inch delta, you can see what we did was we took a little bit of a bite out of the concrete footing there, right? So there's our concrete footing, but notice we now have a shelf introduced there. And the shelf is oversized by 3 inches. I say oversized, but it's actually the same size because that 3 inches gets made up by the double mud sill. But the floor joist would sit on top of that double mud sill. And now the floor joist, floor joists there are sitting down on this double mud sill. So that is just simply the same displacement from top of foundation on both shelf and foundation. And what that does is that then allows that the bottom of the floor joist there is basically the top of the floor joist on the lower section. So that's how we do it. You can take that little bite out of the foundation wall there. We build a shelf in there, and now instead of sitting on top of the foundation wall, we're sitting adjacent to the top of the foundation wall. We're dropped 14 inches. Things align. I'm happy, but most of all, our client is happy. They have a nice, easy stairway to negotiate to get into the mudroom. They have a couple steps from the mudroom up into their main part of the house there, which is easy to negotiate. They never have to clean. There's no maintenance to them. They're inside the house. They look nice. You get a little floor differentiation there. The ability to change flooring type, flooring finish from tile to wood floor. So everybody wins. One of my pet peeves, fully explained to you. So hope you enjoyed it. Look forward to seeing you here in the future on the Build Show. If you haven't seen my previous videos, I suggest, go check them out. Check out my colleagues, Wade, Jake, Matt, and Brent. Guys are always doing something really cool. Wade built some beautiful houses on the coast. Jake is always up to no good in a good way, trying to just get better at what he does. Guy does a superb job as an inquisitor and always trying to find kind of that next level of information. Brent brings just his wealth of knowledge about architectural style and how to put together some of these period homes that he does, which is just amazing work that he's doing down there. And then, of course, Matt. We all know Matt. And, together we're all trying to lift all boats. So until next time, thanks for joining me here. Long live our buildings.